We are continuing the conic sections with the last conic section. As you recall, we looked at a hyperbola already, and the foci is a little further than A, which is kind of strange considering how ellipses are. And so you can remember these things. A is the distance from the center to the vertex, okay? And C is the distance from the center out to the foci, or to one focus, okay? And we have transverse axes, they're the long ones, and we have conjugate axes, they're the short ones. We'll get to that more here in a second. You can see that the order really matters, and we have subtraction in these as opposed to ellipses. They're very close to ellipses, but there's a subtraction sign, so it matters, and sometimes y gets to go first. It's wonderful for y. There is no reason why we can't write y this way for ellipses too. Why not let the y go first? Why not? But anyway, we have to let the y go first because of the subtraction. Order matters in subtraction. These formulas down here, again, they're fine if you are starting with your center at the origin, but usually you're not. So they seem like a little bit of a waste of time. I would definitely focus on these two. How would we know which to use? Well, if it's horizontal, that is to say if they're like this, down here. This is the horizontal version right here. And if they're vertical, that means the y goes first. See the y going first? Then they're like this. They're going up and down. Okay, so you get the idea. I hope you remember. The asymptotes of a hyperbola, we can find them with these fancy formulas. And sometimes we might need to use those fancy formulas. But most of the time, we're going to say, hey, I know how long A is. There's A. Okay. And I know how long B is. It's going, the conjugate axis here is B. So I can build this rectangle. I can build a rectangle around the whole thing using A and B, because since I know where they are. I can extend everything into a rectangle. And now I have this rectangle, and if I use that rectangle, I can go from point to point in the rectangle and keep going, and that's my asymptote, okay? So I keep going, and that's my asymptote. And again, I go from one point to the other point exactly, and then just keep going, that's my asymptote, and extend it in the other direction too. Those are my asymptotes, okay? So if I'm just sketching it, most of the time that's what I'll do. But if I need the formulas, fine, I'll use the formulas. I have mentioned before that I would prefer to have k over here because I'm thinking of y equals mx plus b, and k is like my b, okay? That's where I'm going to hit. You won't notice, if it's at 0, 0, if I'm at the origin. But anyway, and then I hope that makes some sense to you. The slope, m, is out here in front. That's the slope, okay? So anyway, I'd kind of like it if Larson made it look the same a little bit for my sake, but that's okay. Whatever. That's fine. Okay, so finding the standard equation of a hyperbola. In exercises, we say find the standard form of the equation of the hyperbola with the given characteristics. Okay, so it's really vital that we graph these points to see what we're dealing with. So let's see. 2, 3. 2, 3 is up here, so we'll call that 2, 3 right there. And my other vertex is at 2, minus 3. And so I'm about down here. Okay, we're going to call that 2, minus 3. I guess so. Maybe a little bit more, a little further. 2, minus 3, if this is 2. So I think I know where my center is. Looks like that's my center right there, right? My center is going to be at 0. No, not 0. My center is going to be at 2, 0. That's my center. Okay. So I know what h is. H is 2, and I know that k is 0. Okay, so that's helpful. And it passes through a point, 0, 5. Okay, so let's see here. It passes through a point 0, 5, 0, 5. We're up here. Oh, I didn't really leave myself enough room, but let's say it's right there. Okay, so I know that my asymptote's going to look something like this. It's going to look, obviously, if these are my vertices, this is a vertical hyperbola. It's going to be something like that. Okay, vertical hyperbola. And so let's see. Now I need the formula, don't I? Okay, because I'm going to say that there's a slope here, okay, because I know there's going to be, well, let's see, that's going to be my asymptote, so it's not actually going to hit the asymptote, so maybe I still don't care, okay, but it has to satisfy. You know what I was thinking about doing? I was thinking about saying, let's see, I know, I'm just going to guess here. We've got some sort of rectangle, remember. I don't know how far out to go. Let's just say it's like this, okay? And I was going to do this kind of thing. What color should I use? Oh, I don't know. I used all the colors. Let's try this one. We'll go like this, okay, and I'd have this like this, and I'd set this up like this, and I'd say, okay, here are my asymptotes, I didn't draw it according to this. This is not too beautiful here. I'm sorry about that. But I was actually thinking about, I kind of had the slope on the brain, so I was thinking, it's gonna hit the asymptote. Well, no, it's not gonna hit the asymptote. It's never supposed to hit the asymptote. So that was a bad instinct I had there. Okay, so let's go ahead and let's think about this. We know the slope. Well, sorry. Slope on the brain. We know this is vertical, so we're going to say y minus k squared over y gets the a because it's the boss minus x minus h squared over b squared, okay, is equal to 1. We know that. Okay, we know that. And we also know some other things. Let's see. We also know that we know a value for x and y, don't we? Okay, here is a value for x and y. And we know a. The only thing we don't know is b. Okay, so let's see what we do here. We're going to say, maybe you'd like me to write this in an intermediate step. Let me write this as an intermediate step. Y minus 0, so just y, over a squared minus x minus 2 squared over b squared is equal to 1. And then we're thinking to ourselves, well, let's see, y squared over, I know what a is. A is 2, right? Y is, a is 3. A is 3. Because look, it's from here to here is 3, right? This is 3, and down here is negative 3. So we were at 2, we went up 3, and we went down 3. So a, that's 3. A is equal to 3. Okay, so sorry about that. I had the wrong thing. So we're going to say 3 squared minus x minus 2 squared over, I don't know b. Okay, so right now there's 3 things I don't know. Once they gave me a point, now I kind of know some things. So let's see. I know that y is 5, so I'm going to say 5 squared. Hey, if it's on the line, it's good for the whole thing. So y is equal to 5, at least right there it's equal to 5, over 3 squared, minus x is 0, so I just have negative 2 squared, right, over b squared is equal to 1. So the only thing they did not give me for this point up here that I highlighted, that point right there, okay, that point, which is 0, 5. At that point, this equation works, okay? So I have 25 over 9 minus 4 over b squared is equal to 1. Well, now there's only one thing I don't know, and it's b squared. So let's solve for b squared. So let's see. How about this? We'll say, let's subtract 25 over 9 from both sides. And that's 9 over 9 minus 25 over 9. And that's going to be minus 16 over 9, right? And then, don't really like the b squared down there. Let me rewrite this. We'll say minus 4b squared over b squared is equal to negative 16 over 9. I'm going to multiply both sides by b squared. You know, while I'm at it, let me just multiply by negative b squared, so I can get rid of that negative. And let's see here. What do we got? We have 4 is equal to 16 over 9 b squared. I don't want that fraction there, so I'm going to multiply by the reciprocal. 9 over 16 takes care of that. And I will have 9 over 4, because the 4 cancels with the 16, and b squared is equal to that. So in my book, b is equal to, take the square root of both sides, 3 over 2. So b is equal to 1.5. Okay? So what do they want? Find the standard form of the equation. Okay, I'm ready to write it now. I have y squared over 3 squared minus x minus 2 squared over 3 over 2 squared is equal to 1. If you just want to write, you know, 9 over 4 down there, I don't know if that's better. Anyway, there we go. That's it. That's the standard form of the equation. So we had to figure out the one thing we're really hunting for, and so there we go. That's the deal.